Hello and welcome to the 21st IGCSE Maths tutorial, and today we're doing graphs. But you may be wondering why my background is white. And my background is white mainly because of something I'm about to show you. This graph paper. So we're going to be referring to this graph paper every now and again while we're doing our work on graphs. And we're starting with drawing accurate graphs. So say we have to draw an accurate graph from 1 to 4. 1 to 4. 1 to 4 for the formula y equals 2x plus 3. We can do this, and we also want to find what is the value of 2.5 using the graph. So the first step really is to draw a table. Now 1, 2, 3, and 4. So 1 is going to be 4. 2 is going to be 2x plus 3. 7. This one's going to be 9, and this one's going to be 11. Okay. So now if we go here, I'll just bring out my trusty ruler book. I can't use a plastic ruler because it'll interfere with the iPad screen, so I have to use more of a plastic ruler. Draw some lines. And we'll do our... It's not quite right. And we'll do our line like that. Just cover this up. Perhaps not. Okay, and we'll do our thing. I'll do all points. And we always use X's and not dots for Cambridge. So 1, which is going to be here, is going to be 4. So we put an X here. It doesn't need to be so big, and 2 and 7. So we put an X up here, and we could put an X at 3 at 9 as well. And we could also put an X at 4, 11. And these X's, you may have noticed, form a straight line. Yeah, they form a straight line. And each time you're going up 2. Wait a minute. 7, that's 4. Is it just me? These form a curved line. Ah, yes. This should actually be a straight line. Yes. This one here should actually be a 5. We can erase that one there. So anyone in the form something x plus something else or minus is going to be a straight line. And that's how I knew something was going wrong. Okay, now I can bring out my ruler and just roll these together with black. Now this is a accurate graph. Now we have to find out where 2.5 is so we can find an accurate value for it. And 2.5 just happens to be here. If we go up to 2.5, we happen to find it's right there, and that is at right, sorry, 2.5. So this is when x equals 2.5, by the way. Y is going to be equal to 8. We can check this on a calculator. Comes out to 8. So that proves we've drawn an accurate graph. So back to here again. We also need to know how to draw gradients. And the gradient formula is just simply G. It's represented by M equals just the rise over the run. Okay, rise over run. This is our formula book for now. Okay, rise over run. So here, so we've got just a line running through here. Okay, we have to find the gradient of this line. So the first step is to find a point where it exactly touches another point. That seems to be, and the bigger the triangle, the more accurate your gradient will be. So let's go for this one. So we first draw a triangle down and sideways, so they join up. And we find their rise and their run. Each square represents 1 unit, by the way. So this is 15 units here. And this is, how many units is this? This is 8 units here. Now because gradient equals rise over run, M is equal to 8 over 15. Okay. And in Cambridge, we're at this level, we're going to use this formula for straight lines, where M is the gradient and this is the y-intercept. Basically when x is equal to 0, or y-intercepts with the y-axis. Okay, let me find the equation. And you can also, once you've found the gradient, you can also find the y-intercept quite easily. So yeah, without even drawing a graph. So we're going to try by starting to plot a curve. Now plotting curves is not easy. It takes a lot of practice. So y equals x squared. We'll start with a basic one. Let's put our axes down. And there they are. So, y equals x squared. We can draw a table of values again, but we don't really need to. Now, we're just going to represent these with tiny crosses this time. So, 1 squared is just 1. What is 2 squared? 2 squared is 4. Now, what is 3 squared? It's 9. And 4 squared, we should all know, is 16. And yes, this definitely doesn't form a straight line, and 0 squared, by the way, is also 0. This definitely doesn't form a straight line. So we need to try and draw a smooth curve through all the points, and this takes a lot of practice. Now, you can turn the paper around, because there should be one way to draw it, which is easier. For example, I'm turning my iPad upside down so I can draw it like that. If you're right-handed and you're drawing a curve like that, or if you're left-handed, you might prefer just doing it right way up. It's a good trick for drawing graphs. And here we have this reasonably accurate y equals x squared graph for the range 4 to 0 to 4. You also need to know how to represent for different graphs. This one is called This type is called a quadratic. And it can also have y equals x squared plus 2x plus 3. Okay. Now, we can also have a type like this. Just need to go to black again. I'll just draw it up. There's this form, which is in the y equals a to the power of x. And this is called a exponential. This is an exponential graph. And you also need to know the shapes of some curves. For example, if I just put my y-axis in the wrong place for this. There are parabolas. Some people call them parabolas, but I call them parabolas. That's the sort of shape of a parabola. There is what sort of look like a U or a U or an upside down U. Those are all parabolas. Parabolas, sorry. There's also hyperbola, which looks like this. Or sort of like that. And there's also a circle, which, as I'm sure you know, looks like this. So there's not actually much to do in graphs, really. We'll just do speed time graphs before we leave. Basically, in a speed time graph, there's only one thing you need to know. The acceleration is the gradient and the distance is the area. So on a speed time graph, so like this one in here. So the acceleration is the gradient of the speed time graph. For this is 0 seconds and this is 0 and 10 and 20 and so on. So we can find the acceleration by using the gradient and say this is 15. It's going to be 15 over 10. 3 over 2 is the acceleration, meters per second. So it's 15 meters, 10 seconds. 1.5. And we can also find the area, which is just the triangle plus this, and it comes out to area of the triangle is 1 over the base times the 1 over 2 times the base times the height, and this will tell us the distance. And the base is 10 times the height, which is 15, plus 30 times 15 comes out to 525 meters traveled. So, thank you for watching, and if you have any questions, leave them in the comment section, and I'll get back to you as soon as I can. I guess I'll see you next time for sets, vectors, and functions. See ya!